Welcome back to Daily Dose of Space. For generations, we have looked up at the night sky and felt something pull us outward. The stars feel close, familiar, almost reachable. When you see images of distant galaxies, it's easy to believe that one day humanity will spread among them, just like we spread across Earth. Science fiction has trained us to expect that future, starships jumping between stars, humans colonizing distant worlds, entire civilizations living far from the sun. But today, we need to slow down and ask a much harder question. What if interstellar travel is not just difficult, but fundamentally unrealistic? What if the universe is not waiting for us to explore it, but quietly reminding us of our limits? Tonight, we're going to explore why traveling to other stars might never happen, not because we lack imagination, but because the universe itself may not allow it. And the deeper we go, the more uncomfortable this realization becomes. The distances that break the human mind. The first problem with interstellar travel isn't technology. It isn't fuel. It isn't even money. It's distance. We tend to underestimate cosmic distances because our brains evolved to survive on a planet just 12,700 kilometers wide. On Earth, crossing an ocean feels extreme. Flying to the other side of the planet feels like a major journey. But space does not scale that way. The nearest star system to us, Proxima Centauri, is about 4.24 light-years away. That sounds manageable until you translate it into something meaningful. Light, the fastest thing in the universe, takes over 4 years to get there. Nothing with mass can reach that speed. The fastest spacecraft ever built by humans, the Parker Solar Probe, reaches speeds of around 430,000 miles per hour. That sounds incredible, but at that speed, reaching Proxima Centauri would take over 6,000 years, not generations, civilizations. And that's just the nearest star. Every additional star lies exponentially farther away, scattered across a galaxy that is 100,000 light-years wide. Even if we somehow built ships 10 times faster than anything we have now, interstellar travel would still be measured in centuries or millennia. This creates a problem that technology alone cannot solve, because distance isn't just about how far you travel, it's about time. Time breaks systems, time breaks machines, time breaks people, and time may be the greatest enemy of interstellar travel. But what if we could simply go faster? This is where things start to fall apart. The speed limit of the universe. There is a reason science fiction relies so heavily on faster-than-light travel. Without it, the story collapses. Unfortunately, faster-than-light travel collapses too. According to everything we currently understand about physics, the speed of light is not just a challenge, it is a hard limit. As an object with mass accelerates closer to light speed, its energy requirements increase dramatically. Push it further, and the required energy approaches infinity. In simple terms, the universe does not allow shortcuts. Even reaching a small fraction of light speed would require energy on a scale comparable to entire nations or even planets. And that energy has to be stored, controlled, and released safely inside a spacecraft carrying humans. This is where theoretical ideas like warp drives or wormholes often appear. On paper, some of these concepts are mathematically allowed, but they rely on forms of matter and energy that we have never observed, never produced, and may not even exist. Negative energy, exotic matter, stable space-time distortions. These are not engineering problems. They are questions about whether reality itself cooperates. And even if such physics were possible, there's another issue we rarely talk about. Speed doesn't just move you through space, it moves you through danger. At interstellar velocities, even a grain of dust becomes lethal. A collision with a particle smaller than a grain of sand could release the energy of an explosion. Space is not empty enough to ignore this problem, especially over light-year distances. Shielding against this kind of damage adds mass. Mass adds energy requirements. Energy requirements spiral out of control. This creates a loop that becomes almost impossible to escape. And even if we somehow solved all of that, there's still a far more fragile component aboard any starship: the human body. Humans are not built for the void. Humans are the product of a very specific environment. One gravity, one atmosphere, one magnetic field, one stable biosphere. Take away any of those for long enough, and the consequences become severe. We already know what happens to astronauts after just months in space: muscle loss, bone density reduction, vision problems, changes in brain structure, immune system alterations. Now imagine decades or centuries. Generationship concepts suggest that humans could live, reproduce, and die aboard massive spacecraft, with descendants eventually reaching another star system. But this idea assumes social stability, biological viability, and psychological resilience across timescales longer than recorded human history. No society has ever remained stable for even a few hundred years without profound transformation. Cultures evolve, beliefs change, priorities shift. A generationship does not just need to survive mechanically, it needs to survive socially. And that raises an uncomfortable question. What if, after centuries of travel, the people aboard no longer want to arrive? What if the mission loses meaning? What if Earth becomes a myth, the destination a legend, and the stars outside simply the walls of a closed world? And even if a crew did arrive, they would not arrive as humans adapted to that new planet. They would arrive fragile, altered, and possibly incompatible with the environment they hoped to colonize. Which leads to another hard truth. Even if we reach another star, it does not mean we can live there. The illusion of habitable worlds. We often hear about Earth-like planets, potentially habitable worlds, places that could support life. But habitable does not mean comfortable. A planet can be in the so-called habitable zone and still be lethal. Radiation levels could be extreme. Gravity could damage human organs. Atmospheric composition could be toxic in subtle ways. Even small differences matter. A slightly thicker atmosphere changes weather patterns dramatically. A slightly stronger gravity increases long-term strain on the heart and skeleton. A weaker magnetic field exposes the surface to stellar radiation. Terraforming is often proposed as the solution, but terraforming a planet is not like adjusting climate on Earth. It would require altering an entire world's atmosphere, temperature, chemistry, and possibly even geology over thousands of years. This assumes levels of energy control and planetary engineering far beyond anything we currently understand. And all of this effort would be directed at a planet light years away, with no guarantee of success, no resupply, and no easy return. At some point, the question changes. Not, can we do this? But, does this make sense? Because the universe may be telling us something through its structure. It may be telling us that stars are visible, but not reachable. That the galaxy is observable, but not colonizable. And that brings us to the most unsettling idea of all. A quiet universe and our true future. Interstellar travel might not be impossible in theory, but it may be impossible in practice. Not because humans are weak, but because the universe is vast in a way that resists expansion. The laws of physics don't encourage us to spread outward. They encourage us to stay local. This could explain something else that has puzzled scientists for decades. If interstellar travel were easy, the galaxy should be full of visible civilizations. But space is silent. No probes, no megastructures, no clear signs of expansion. Maybe advanced civilizations don't disappear. Maybe they simply stop trying to leave their stellar neighborhoods. Perhaps intelligence doesn't conquer the galaxy. Perhaps it learns to optimize where it is. If that's true, then humanity's future may not lie among the stars, but around them, in mastering our solar system, in understanding our planet, in building stability rather than escape plans. Interstellar travel captures our imagination because it represents freedom. But real maturity may come from accepting limits. The stars will always be there, distant and beautiful, reminding us of how small we are. And maybe that was never an invitation. Maybe it was a lesson.